Hi guys, today we'll be starting on a new e-learning topic, Chapter 9, Trigonometry. For this particular e-learning, we'll be focusing only on two parts, 9.1 and 9.2. So starting with 9.1 on Introduction to Trigonometric Ratios, we will be learning what exactly is a trigonometry, the definition of trigonometric functions or ratios, and evaluating trigonometric ratios using the right-angled triangle. So what exactly is trigonometry? The word trigonometry can be broken into two words, trigonon and metro. Trigonon in Greek actually means triangle, and metro is a Greek word which means measure. Trigonometry is actually the branch of mathematics that deals with relating the angle and the length of the sides of a triangle. Why so? Because we know that triangles have three sides and three angles, and what trigonometry does is to relate these three angles to these three sides. For the purposes of this syllabus, we will only be focusing on the right-angled triangle in Sec 2. In Sec 3, you will learn to deal with trigonometric ratios of non-right-angled triangles. But for now, we will focus only on right-angled triangles. But before I move on, I have to introduce a few special things about this right-angled triangle to you. So let's take a look at this right-angled triangle ABC. What exactly is theta? Theta is actually what we call the angle of interest or the reference angle, because all the lengths of the sides, or rather just these two sides, actually take reference from this particular angle. The next thing I'm going to introduce to you is something that is not unfamiliar to you. It's called the hypotenuse. You will have learned this in Pythagoras' theorem. The hypotenuse is just the side, the longer side which is opposite the right angle. The opposite is actually length AC. It is basically the side that is literally opposite the angle of interest. That's why it's called the opposite. And the last side here is actually called the adjacent. The adjacent is the side which is next to the angle, because adjacent means next to, right? So adjacent side is next to the angle, but it is not the hypotenuse. So please familiarize yourself with these four terms, because we will be using them quite a fair bit in the later examples. Now moving on, what exactly are trigonometric ratios then? Okay, the main functions in trigonometry are the sine function, the cosine function, and the tangent function. Okay, how exactly are they used? We will usually write sine of a certain angle equals to a certain ratio, cosine of a certain angle is equivalent to a certain ratio, and tangent of a certain angle is equivalent to a ratio. Now notice, these three things here are actually the short forms of sine, cosine, and tangent. We basically took the first three letters of each full word and put it as a function. Take note that these things are not algebra, they cannot be cancelled. Okay, and every time I key in sine with an angle, it actually gives me a value which is a ratio. Now I want you to think about this. Do you think these trigo ratios over here have units, and why? Pause the video for a while and think about it. Alright, I hope that you have had some time to think about it. Okay, if you had guessed that trigo ratios do not have units, you are absolutely right. Trigo ratios are just like any other ratios. They do not have units. Why? Because the units will cancel out when I write them in this form. Okay, so please take note, when you put the trigo ratio, when you put the angle inside the trigo ratio, you are not finding a side or length or something, you are just finding a ratio. So how do we relate this back to the right-angled triangle? Okay, so given a right-angled triangle, the trigonometric ratios are actually defined as such. Okay, so just to quickly recap, this side over here is the hypotenuse. This side over here, which is opposite, the angle of reference is the opposite, and this side over here is the adjacent. So sine of the angle of interest or the angle of reference, okay, is defined as the opposite side over hypotenuse, opposite over hypotenuse. In this case, it is length AC over length AB. Cosine theta is actually defined as adjacent over hypotenuse, A over H. And in this case, it is BC over BA or AB. Tangent theta is defined as opposite over adjacent. In this case, it is AC over BC. Okay, so how do you remember these three ratios? I teach you a very easy way. Just remember this phrase, tua ka so. Tua ka so. Now, some of you who may know a bit of Hokkien might actually know that this means big leg auntie in Hokkien. Okay, so just remember tua ka so. Tangent is opposite over adjacent. Cosine is adjacent over hypotenuse. And sine is opposite over hypotenuse. Alright, so we have come to the end of the first part of this e-learning. Okay, now you may log on to YouTube to find out more about this guy called Jonathan Mann. He has made this music video on this this song, teaching you how to remember the different trigonometric ratios. Okay, please also at this point don't forget to do the checkpoint questions. Your teacher will go through them with you in class. Alright, so I'll see you in the next video where I'll give you a few examples on how to apply these trigonometric ratios. Thank you.